Alright, so now we're on part 5, question 1, and in this case we have a bunch of ideas. As for startup companies, we have 10 ideas in a notebook, and we want to make sure that the amount of money we gain in the end, the net total amount of money we gain in the end, is going to be non-negative. So we don't lose more money than we make. So net xi's here be net profit from idea I, and let T be total net profit. Saying total and net kind of defeats the purpose of saying total or net, but whatever. Total net profit overall, right? So T is going to just be sigma I is equal to 1 to 10 xi. Right, so first let's calculate the expectation of xi and ti and variance of xi and ti, and also let's work in dollars instead of thousands of dollars. So instead of $100,000, let's work with $100, because with the probability we're going to get is going to be exactly the same, and it's just going to make our calculations much easier to work with this. So expectation of xi, it's you gain $150, but you lose 50. So with probability P, you gain $100, and with probability 1 minus P, you lose your $50, right? Which is just equal to 150 P minus 50. Now variance of xi, since this is actually just a binomial distribution, so you have 10 different values, and they can either take 150 or negative 50. But it's shifted by 50 down behind 0. So it's actually, you're shifting the distribution of 0 and 150 back. But shifting a distribution doesn't change the variance. So this is just a scaled binomial distribution. So it's 150 squared, because instead of being 0 and 1, you have 0 and 150. So it's 150 squared times P times 1 minus P. So you can also calculate this but just using expectation of xi squared minus expectation of xi the whole squared, and you'll get the same thing. So yeah, you can check that if you want. Now since all the xi's are just independent of each other, let's calculate expectation first. We can calculate the expectation of t to just be 10 times expectation of xi, and variance of t to be 10 times variance of xi. Alright, now that we have this, let's try to see how we can estimate what we should, with what probability we need to gain, or we need to be able to have our ideas to be successful to actually make sure that we net a positive amount with greater than 95% probability. Yeah, I muddled those words, but I'm just restating the question. So we want to make sure the probability of t less than 0 is greater than 0.05, right? Or rather, it's less than. We want probability of t less than 0 to be bounded by 0.05%. We want to lose money with probability less than 0.05%. So let's just try to write t less than 0 in terms of something which we can use Chebyshev's inequality for. Just probability of t less than 0 is probability that negative t is greater than 0, which is equal to probability then expectation of t, I'm adding expectation of t to both sides, is greater than expectation of t minus t is greater than expectation of t, right? And this is less than equal to probability of expectation of t minus t greater than equal to expectation of t, because the event that expectation of t minus t is greater than equal to expectation of t has a little bit more space, or it has more things happening in the event above here. It's just a subset of the event below, so therefore the probability of the event above is going to be less than equal to the probability of the event below. So now let's add something to this second term, let's add a non-zero probability plus probability of t minus expectation of t greater than equal to expectation of t. So we're adding something. Since probability is going to be between 0 and 1, it's a non-negative quantity, and we're also adding this event. And this is because we want to bring it in terms of a form where Chebyshev inequality likes. So what we're saying in this line over here is just that the probability that expectation of t and t are more than expectation of t apart, or the distance between these two numbers is more than expectation of t, that's the event the probability above, or the line above, is bounding or is equal to. So we can just substitute that by the absolute value sign. Now this is just what what Chebyshev's inequality is very used to seeing, or you are used to seeing in terms of Chebyshev's inequality, except you see those two are turned like are flipped around, but since it's the absolute value sign, it doesn't really matter. Now this from Chebyshev's inequality is less than equal to variance of t divided by expectation of t the whole squared, and this we want to bound by 0.05. So now let's go here. Now we know from above there that expectation of variance of variance of t and expectation of t can be written in terms of variance of xi and expectation of xi, right? So variance of t is just 10 times variance of xi. I'm just taking this and going there. 10 times expectation of variance of xi, and expectation of t is 10 times the variance of xi. 10 times the expectation of xi. So therefore the whole squared, you're going to get 100 at the bottom. Expectation of xi, this you want to be less than equal to 0.05. This implies 110 gets cancelled, so, and 10 goes up. Therefore you want variance of xi to be less than equal to 0.5 times expectation of xi. Now when we substitute in the values which we found above, I'm just going to write the quadratic equation, but it's just going to be simple algebra, and you'll get the same thing. Which is equal to 33,750 p squared minus 30,000 p plus 1250 greater than equal to 0. That's what we'll get for our quadratic equation when we replace variance of t with whatever value we found above, and variance of xi with whatever value we found above, and expectation of xi with whatever value we found above. The whole squared. Sorry, there's a whole squared there, right? Now this will give us two values for p. If you solve this, you'll get p greater than equal to 1 over 9 times 4 plus root 13, which is equal to 0.845. My 5 looks like a 6 and my 4 looks weird. 845, or p less than equal to 1 over 9, the other root, times 4 minus root 13. This is equal to 0.0438. And obviously you don't want p to be less than equal to 0.0438, because that means that the probability of your success is going to be very, very low. So this, whoops, that is not nice. Okay, yeah. So this is going to be your final answer. You want, I'm going to write it here in a big box. So you want p to be greater than equal to 0.845 if you want to have a probability of less than 5% of losing money. So that's it for our question, part 5, question 1.